Hello students, let's look at integration as an overview. The process of integration, it is opposite to that of differentiation, and the result obtained in integration is a higher grade function than the given function. For example, integral of x is x square by 2. Its degree is more than that of x. Degree of x square by 2 is more than that of x. Then integrals are defined as limits of Riemann sums, and we can see in another video how we can define integrals as limits of Riemann sums. Now we have two types of integrals, definite integrals and indefinite integrals. Definite integrals are integrals evaluated over closed intervals, and when we write the integral, we write like integral from a to b, integral from 2 to 3 x square dx. For example, those type of integrals are called definite integrals. And if we have no specific limits, we can write integral cos x, and we write a general result as the value of the integral. Such integrals are called indefinite integrals. Then we come to the formal definition of integrals or the process of integration. Earlier we have stated that it is a process opposite to that of differentiation. So it is connected with the differentiation. Differential of capital F of x is small f of x. Means integral of small f of x is capital F of x. Note that capital F and the small f are used to indicate the higher grade function obtained in integration. Integral of small f x result capital F of x. എന്തോ കുറച്ചുകൂടി വലുതാണ് എന്ന് കാണിക്കാനാണ് നമ്മൾ ക്യാപിറ്റൽ എഫ് എന്നുള്ള നൊട്ടേഷൻ ഉപയോഗിക്കുന്നത്. So integrals are called antiderivatives. Likewise, when we say b is the son of a is the father of b, fx is the son, small fx is the son, capital Fx is the father, or it looks like the parent. Capital Fx is something bigger than that of small f of x. Integral is something more than, something higher to that of the differential. Then some examples. You know that differential of sin x is cos x. So we write integral of cos x is sin x. Differential of x square by 2. Note that it is x square by 2. Differentiation 2x divided by 2 will give x. So integral of x is x square by 2. Differential of e raised to x is e raised to x itself. So integral of e raised to x is e raised to x itself. These are some examples, and we have some general rules corresponding to trigonometric, algebraic, exponential functions, and using that general rules we can evaluate the integrals of any of these combinations. Then we can compare and contrast with the differentiation and integration. Differentials are defined at a single point, dy by dx at x equal to 5, x equal to 10, etc. we write. But integrals does not exist at a single point. Actually, the value of the integral from 2 to 2 f of x, if we write that, it is equal to 0. So it has no existence, no meaning. Integrals are defined over closed intervals. Integral from 1 to 2 x dx എന്നൊക്കെയാണ് നമ്മൾ എഴുതുക. But differentials have no such existence. ഒരിക്കലും നമ്മൾ ഡിഫറൻഷ്യൽസിനെ അങ്ങനെ ഒരു പോയിന്റ് തുടങ്ങി മറ്റൊരു പോയിന്റ് വരെ കണ്ടിന്യൂസ് ആയിട്ട് അങ്ങനെയൊന്നും എഴുതാറില്ല. Some difference and scalar product rules in differentiation can be extended to integration in a similar manner, but the product rule of differentiation cannot be generalized to integration directly. There is nothing like product rule in integration. You have not studied product rule of integration. Instead of, we have integration by parts, and note that it can be applied to any product like differentiation product rule. If u and v are any two functions, product uv has differential u into derivative of v plus v into derivative of u. No restrictions for u and v. But when we find the product, when we find the integral of a product, uv എന്നൊന്നും നമ്മൾ എഴുതാറില്ല, ഫസ്റ്റ് ഫംഗ്ഷൻ ആൻഡ് സെക്കൻഡ് ഫംഗ്ഷൻ എന്നാണ് പറയുക. Then first into integral of the second minus integral of derivative of first into integral of the second. It cannot be applied to any two functions. We take a function with the terminating derivative as first function. For example, if we have e raised to x and x, we write x into e raised to x in that order, because the derivative of e raised to x is e raised to x. If we differentiate any number of times, എത്ര തവണ ഡിഫറൻഷിയേറ്റ് ചെയ്താലും e raised to x ന്റെ ഡെറിവേറ്റീവ് തീരത്തില്ല. But the derivative of x is first time 1, second time it is 0. After a finite number of stages, if the derivative of one function yields the value 0, then we can use that function as the first function, because of the rule of integration by parts. Second part minus integral of derivative of first. Then derivative terminating function can be taken as first function to end the procedure. Otherwise, the process will repeat infinitely. So, we are taking the first function as derivative terminating function. These are the different rules of integration in comparison with the rules of differentiation. Similarities are only in some difference and scalar product rules. Only similarity. And the other rules or other properties are very different from that of differentiation, actually opposite to that of differentiation. This is an overview of integration, and you can see in detail Riemann integrals, application of integration to finding area, etc. So watch those videos also, and after that I will put an assignment. Then you have to submit the answers of the assignment. Writing notes of these videos is up to you. This is not part of our syllabus, but only for a review or for an introduction we are doing these videos. So do it sincerely and let us understand the concept of integration well, so that we can proceed easily in the next classes. Okay, thank you.